In a football game attempts a field goal 45 yards from the goalpost. The ball is on the ground and is kicked with an initial velocity of 71 feet per second at an angle of 58 degrees. The height of the crossbar on the goal post is 10 feet, as shown in the diagram. So to do it manually, you can use the projectile motion equation, which I already plugged in the values into the equation, but let me show you why. 32 is because of we're using feet in the equation, and 71 is the initial velocity, 58 degrees is the degrees, and then we put plus 0 because it starts from the ground, as it says right here. And for x, this is the initial velocity, the angle, and we use cos because it's x. Okay, so I went and already did the graph, but I changed I went to trace step, and I put 0.001 enter, and I moved all the way until it hit 135 and 134. I went to the first 135 and just 10.8. So if you were to round it, if you keep on going, it's 10. It doesn't go over 10, so it would hit the crossbar. So it cannot be determined as a field goal. And to do it manually, you use the same equations, except since we're using feet, you have to turn 45 yards into feet. So there's 3 feet in a yard. So 45 times 3 is 135, which is why we plugged in 135 into x, because that's the horizontal length. And then for y is 10 because the goalpost is 10 feet. And we plug that in, and so we end up dividing 135 divided by 71 cos 58. So t equals 3.5881. And to find y, we plug in t into the equation. After that, we get y equals 10.05. So it still hits the crossbar, and that's why the answer is D.